Let's find out about moments. What is a moment? A moment is a turning effect around a pivot or fulcrum. How to calculate a moment? A moment depends on force and perpendicular distance of the force to a pivot, as shown by the equation. Moment in Newton meters equals force in newtons times by perpendicular distance of force from the pivot in meters. M equals F times by D. Rearranged, the formula looks like this. Force equals moment divided by perpendicular distance, or perpendicular distance equals moment divided by force. The moment gets bigger if the force gets bigger. The moment also gets bigger if the perpendicular distance of the force from the pivot gets bigger. Spanners are a type of lever and are capable of creating very big moments or turning effects to loosen very big nuts. Using levers to create moments, either to make an object turn or to lift an object. Whenever you're using a lever, you need to identify the pivot, the effort, and the load. The pivot is the point around which everything turns. The effort is the force that the user applies. The load is the force that the user must lift or turn. Using levers to lift an object. Levers are often used to make it easier to lift an object. Let's look at these two acrobats using a seesaw, or teeter-totter if you're from America, as a lever to take turns lifting each other high above the ground. The descending acrobat acts as the effort force, which forces the lever down on one side of the pivot, which makes the lever on the other side of the pivot go up and lift the other acrobat, who acts as the load. Using levers to turn an object. Levers are often used to make it easier to turn an object. In this example, the person is using a spanner as a lever to create a moment to loosen a bolt. The user applies a force of 30 newtons at a perpendicular distance of 0.3 meters, creating a moment of 9 newton meters. However, the moment of 9 newton meters isn't big enough to loosen the bolt. If you need to create a bigger moment, you just need to use a bigger force. But what if you're already using your maximum force? Then what you need is a longer spanner. By using a longer spanner, the force acts at a greater perpendicular distance from the pivot, which creates a bigger moment or turning effect. In this example, although the force was still just 30 newtons, because the distance doubled, the moment doubled and the nut loosens. Quick question: what would happen if the user used a spanner that was 3 times longer? Answer: the moment would get 3 times bigger because the perpendicular distance got 3 times bigger. Clockwise and anti-clockwise moments. There are times when forces act on a lever at opposite ends, like on this seesaw. This creates opposite moments, one being a clockwise moment and the other being an anti-clockwise moment. If one moment is bigger than the other, then the end with the biggest moment will go downward. In this case, that's the end the man is sitting on. It goes up again because he uses the force to push it back up, just to increase the fun for his daughter. The moments are called clockwise or anti-clockwise because they make the lever turn, like the hands of a clock. To work out if a moment is clockwise or anti-clockwise, use this tip. Follow the direction of the force with your finger in a circular motion. Keep going until you get round the back of the pivot. If your finger is moving in a clockwise direction, that force has created a clockwise moment. If your finger moves in an anti-clockwise direction, then that force has created an anti-clockwise moment. In this example, the anti-clockwise moment is the biggest. Quick question: which is the biggest moment in this clip? The anti-clockwise moment or the clockwise moment? Answer: the anti-clockwise moment is the biggest. Moments in equilibrium. If an object is in equilibrium, it means that the object is balanced, which means that the clockwise moments acting on the object equal the anti-clockwise moments. So force 1 times by perpendicular distance 1 equals force 2 times by perpendicular distance 2. Here's an example to explain. When the crane is lifting a load, from our perspective, the load will create an anti-clockwise moment around the pivot. The crane has a counterbalance which will create a clockwise moment around the pivot. The crane operator must move the counterbalance towards or away from the pivot to ensure that the clockwise moment equals the anti-clockwise moment to keep the crane in equilibrium and stop it tippling over, like this. Let's say the crane lifts a load of 20,000 newtons at a perpendicular distance of 20 metres from the pivot. If the counterbalance is 30,000 newtons, what perpendicular distance must the counterbalance be from the pivot in order to keep the crane in equilibrium and not topple over? Here's the answer. Here's a question for you to try. And here's the answer. A forklift truck driver must also balance the clockwise and anti-clockwise moments to stay in equilibrium, otherwise this can happen when they get it wrong. Moments also apply to gears. Watch my video on gears on the screen now to understand. Hope that was helpful. Subscribe to the channel, stay safe, work hard and be nice.